Welcome all. In this video, let's see how to create an application load balancer in AWS, and then how to enable access logs in ALB, and how to store those access logs in an S3 bucket, and finally how to query those access logs from Athena. This is my GitHub, and this is a public repository I've created to demonstrate ALB access logs. Go to Terraform. There you can see the required files. Let's clone this repo in my local. Run this. It is cloned. Navigate to AWS ELB Access Logs folder. Go to Terraform. Okay, these are the contents. I have added another TFRs file, so let's pull the latest code. Okay, so we have downloaded the TFRs file. Edit the TFRs file and then add the account number here. Save the file. Open the main TF file. So I want uh, to explain you this code step by step. So what I'll do, I'll delete all the codes. We will create each resource step by step so that you can understand what we are doing. For safety purpose, I haven't stored my AWS account ID, account number in Git. So that is why we have created this TFS file where in which you can update your account number. You can download the GitHub repository code and then you can edit this TFS file to have your account number. So I will quickly explain what this file contains. So um, if you want to run Terraform, you have to have one main Terraform file. So that is why we have named this file main.tf, which is nothing but main.terraform file. So we can add variables. So I have added a profile and I have given the value A2. It can be anything. So what it means is, so if you open the local AWS credentials file, there you can add multiple profiles like account A1, A2, A3. Since we are going to use account A2 for our demo, I have used profile A2. So this is equivalent to running the AWS CLI command with -- profile A2. And then I'm having another variable called resource prefix, for which I've used the value, default value, my name. You can use any value here. Suppose if I want to create an AWS S3 bucket with this prefix, then the bucket name will be created like this prefix -test bucket. I told you about the account number. You can add your AWS account number here. And this is the ELB account ID for Mumbai region. So you have to use this account number in the bucket policy. And then which provider we are using? We are using AWS. So you can use other providers, other cloud providers like Azure. And I have mentioned the region AP South one, which is Mumbai. And this will be the profile. The profile will be A2. So what are we going to design today? In order to demonstrate what I told you that I'll be demonstrating, you have to have a VPC and then two public subnets. Public subnets are nothing but subnets which have association with an internet gateway through route table. So we should have subnets. We should have at least two subnets, because when you create an application load balancer, you have to mention at least two subnets. Why two subnets? This is for availability. If one availability zone goes down, then the ALB can still use the other subnet. Since subnets cannot span multiple availability zones, those two subnets should be created in two different availability zones. If you create two subnets in a single availability zone, and if you try to link those two subnets in the same AZ with the ALB, you will get an error. So you have to create two subnets in two different AC. That's what we are doing. AP South 1A is an AC, AP South 1B is another AC. So we are creating subnet 1 in 1A and subnet 2 in 1B. When any user from internet uh, wants to send a request to your ALB, those requests from internet will be coming to your subnets through internet gateway. That is why you have to attach internet gateways to your subnets, which will make your subnets public. So what are we going to create now from through your Terraform code? You have to have one VPC, you have to have two subnets, and then you have to attach internet gateway. Let's not create a new VPC, we'll use the default VPC. So that is why we have mentioned uh, data AWS VPC as default. Default is equal to true means it will automatically get the properties of the default VPC. As you know, an account can have only one default VPC. So for this demo, we will be using the default VPC. The next thing we have to do is we have to create subnet 1 and subnet 2. Let me explain the properties. So subnet should be inside a VPC. That will be the default VPC, which is this one. And then you have to mention a CIDR block, uh, a different CIDR block for subnet 1 and a different CIDR block for subnet 2. So these two should be different. And then these two subnets, as I told, should be in different availability zones. So subnet 1 will be in 1A, subnet 2 will be in 1B, and then map public IP on launch. So it will use public IP if you mention it as true. And then you are going to name it as prefix hyphen subnet 1 as its name, and then prefix hyphen subnet 2 as the name of this second subnet. So let's copy this code, paste it here, and then run Terraform plan. Okay, we are getting an error. Let's see what's that. Let's run Terraform init, and then run Terraform plan. So that is going to compute your code, and it's going to tell what are the resources it's going to create. Since we have added only two subnets, so it's telling you according to the plan, I'm going to add two resources, that will be two subnets. So if it is okay for you, you can run Terraform apply. uh, I'll explain about that command when we run that. So without wasting time, let's run Terraform apply. Then you can additionally add auto approve, so that it won't prompt you to enter yes. Let me run this command. throughout this video, I'll pause the video if it is taking too much of time. Okay, it is successfully applied. Let's go to the AWS console and see what it has created. We are using account A2. Go to subnets. There you can see it has created two subnets, subnet 1 and subnet 2. It is created in AC1A and subnet 2 is created in AC1B. Let's check the route table of these subnets. Select a subnet, go to route table. You can see it is attached to internet gateway. Similarly, if you go to subnet 2 route table, it is also attached to internet gateway. So that means these two subnets are public subnets. So we have got public subnets, internet gateway, all those things created. So the next thing is we have to create a security group and we should allow traffic on port 80 from anywhere, that is from IP 00000/0. So why are we creating the security group? Because we are going to create an application load balancer and we are going to attach the security group with that application load balancer so that uh, if a user accesses the application load balancer through Postman or browser, they have to make the communication only through port 80 in this demo. So we have to create the security group so that we can attach this security group with the application load balancer. And if the users send traffic to ALB, it will come through via port 80 to internet gateway, and then from here it will be forwarded to the application load balancer, which will be created in the public subnets. I want to make one more point. So the application load balancer is just a virtual thing. It will not be, though we associate the public subnets while creating the ALB will not be created inside the subnets technically. What will happen? I'll explain about the components of application load balancer, but ALB is something virtual. Um, so the next thing is we have to create a security group. We'll create the security group through a Terraform code. Copy this code to create the security group. Paste it here. I'll explain the contents of it. So we are going to create an AWS security group. And we are going to name it as ALB security group for internal Terraform file reference. The name will be a prefix -ALB -SG. So this is the description and this is the VPC ID, which is the default VPC. What we're saying is allow traffic from anywhere on port 80. So let's run Terraform plan and Terraform apply again. Save this file. Run Terraform plan. So that is telling you I'm going to add one resource, that is security group. Run Terraform apply. Let me pause the video. Okay, it is created too fast. Let's go to AWS console and see this security group. So this is the security group we have created, prefix -ALB -SG, which is created in the default VPC. So go here and see the inbound rules. Outbound rules will be the default, nothing. So we have one inbound rule. Next, we have to create an ALB. As I told, ALB is something virtual. So when you actually create an application load balancer, it is going to create two network interface in the subnets which are associated to the ALB. So when I create an ALB, it will create a network interface ENI on subnet 1 and subnet 2. And this security group will be linked to this ALB. As I told, the traffic will be routed to ALB via the internet gateway. So let's create an ALB now. This is the code to create application load balancer. We are creating an AWS load balancer. Name will be my ALB. This is the name. And is it internal? No, it is not internal. What will be the type of the load balancer? It will be application load balancer ALB. And what is the security group? We are going to link with this ALB. We are going to link this security group, that is AWS security group ALB SG ID. We are going to use this ID. So this is the beauty of Terraform. We don't need to get the ID of the security group we have created and then paste the ID here. You can just refer the other resources like this. Similarly, you can link the subnets. You can link the subnet 1 which you have already created and subnet 2. So enable deletion protection, you are going to set false, and we are also going to enable the access logs. So access logs is nothing but it will capture all the traffic which is coming to your ALB. You are going to save all those logs in an S3 bucket. So we are going to enable access logs and store all these details in this bucket. The prefix will be ALB log. So when you go to the S3 bucket, you can find a folder called ALB-logs where all those access logs will get saved. So is it enabled? True. So we will copy this code and paste it in our Terraform file. Save this file. Let's run Terraform plan. Okay, we are getting an error. It says that the ALB logs bucket, which we have mentioned here, doesn't exist. And that is correct because we are yet to add the S3 bucket. So we will add the S3 bucket as well. This is the code to create a S3 bucket. We are creating a S3 bucket and we are naming this S3 bucket like this. And then I have given force destroy is equal to true. So that when you want to delete all the resources by running Terraform destroy command later, if the S3 bucket contains some data in it, it won't get destroyed. You'll get an error saying that you will not be able to delete this S3 bucket because it contains files. It is not empty. So if you want to delete S3 buckets, even if they have contents, you have to mention force destroy is equal to true. Copy this code, paste it and run Terraform command. Save this file. Now run Terraform plan. So it's telling you that it's going to create an S3 bucket and an ALB. So let's run apply. Okay, it really took a while and we also have got an error. It says access denied for bucket. This is because if you want to enable access logs, you have to give permission in the bucket through bucket policy. So in addition to creating an S3 bucket, you also have to add a bucket policy to that bucket. So let's do that. This is the bucket policy you have to add. Copy this code, paste it here, save the file. Run Terraform plan again. Run Terraform apply. Okay, it is successfully applied. Let's go to the console. Go to ALB, load balances. See, you can see the ALB here. Click on it. The two subnets, subnet 1 and subnet 2, we have created or linked. What are the other things we can check? Okay, this is the DNS name. So we have to call this application load balancer only using this DNS name. And what else? Yeah, you can go to attributes, and then you can see the access logs enabled. This is the S3 bucket, uh, prefix hyphen test bucket. ALB logs is the path we have given. Click on it. It will take you to the S3 bucket. So this is the bucket, and then ALB logs, release logs. So a sample file is also added. Let's go to the bucket and see the bucket policy. The bucket policy is also added. So far so good. So what we have done is we have created an S3 bucket, we added a bucket policy, and we have enabled access logs, and we have configured the application load balancer to write all its access logs into this S3 bucket. So what you're going to do next, we need to create a target group and then link that target group with the application load balancer. That target group will have targets. The targets can be an EC2 instance or ECS containers or Lambda. For simplicity, I'm going to create a Lambda function, a Node.js Lambda function as the target. So we have to create a role and attach a policy so that that role can run the Lambda function. So that role will have the privileges to run the Lambda function. So first thing we need to do is we have to create an AWS IAM role and a managed policy called AWS Lambda Basic Execution Role. So let's do that. Copy this code, paste it here, save the file. It is successfully applied, and let's go to the console. Go to IAM, roles, and then select the newly created role. You can see the managed policy, that is AWS Lambda Basic Execution Role, added to this role. Next thing is we have to create a Lambda function. Copy this code, paste it here, save the file. So we have pasted the code. Yeah, we have saved the file. Run plan and apply. The Lambda function is created. Let's switch to the console. Lambda. I was shocked that I know because I couldn't see the function created. Then I noticed that we have to change the region. So let's select Mumbai. So sometimes this happens. Yeah. So we have created the Lambda function. So this is our role. Let's test this. Yeah, it is going to return you this string hello from Lambda. This is a very simple function. Next, we have to give this ALB permission to access this Lambda function. Copy this code and paste it here. So we are creating an AWS Lambda permission. We are naming it Lambda permission, and this is the statement ID. It is going to invoke the Lambda function. Who is going to invoke this Lambda function? It is the load balancing service, Elastic load balancing service. Let's apply this. It is applied. Let's go to the Lambda function, go to configuration. If you come down, you can see the resource based policy statements. There you can see this statement is added. Next, we have to create a target group and then register this Lambda function as a target of this target group. Copy these codes. This is a code. This is AWS target group resource, and this is target group attachment. We are attaching the uh, function, Lambda function, with this target group. So copy these together and then paste it here. It is successfully applied. Let's switch to the console. This is the target group created. Click on this and then you can see Lambda function is the registered target. Monitoring, you can see these details here. Health checks is disabled now. So you can see all those things. Sorry, you can see all those things. Yeah. Next, we have to add a listener to this uh, ALB and target group. So what it means is, if you get any request or traffic to application load balancer on port 80, the application load balancer is going to forward that request to the target group, which will eventually forward the request to Lambda function. So that when a user sends port 80 traffic from internet, it will go to internet gateway, it will go to ALB, and then ALB will forward that to target group on port 80. Target group will forward that to Lambda function, and you are going to get the response from the Lambda function, that is hello from Lambda. In order to create the AWS load balancer listener, you have to run this code. So copy this, paste it here and save the file. Plan and apply. It is successfully applied. Let's check the console. See, it is this target group is linked to load balancer. Click on the load balancer. Select this. There you can see the listener and rules. It is saying that whatever the traffic which comes on port 80 will be redirected to this target group, that is this. Again, if you click on the target group, you can see the targets. So this is also done. Let's see if the end-to-end request works. That is from internet till uh, the Lambda function. So let's copy this DNS name of application load balancer. Let's run this from a new tab. Okay, it is working fine. Let's check the bucket. So we have the access logs added for today's date, that is 23rd January 2024. So we have the logs added here. That's good. So after this, we have to uh, query the access logs using AWS Athena. So for that, we have to perform few steps. The first thing is we have to create another bucket for Athena. Let's do that. Copy this code and paste it here. Save the file. Plan and apply. It is successfully applied. Let's switch to the console. Yeah. Go to buckets. Yeah. This new bucket is also created. Let's quickly go to Athena. Go to query editor. There you can see a work group called primary. So we are going to make some changes to this work group, primary work group. We have to add a query result location, which will be our Athena bucket. So you have to make changes to the primary work group of Athena. We have to add the query output location. So Athena's work group, primary work group's primary output location will be the newly created Athena bucket. Let's do that now. Copy this code, paste it here and save the file. Plan and apply. Okay, we are getting some error here. So in order to fix this, we have to run this command. Plan again and then apply. Sorry. Apply. It is applied. Let's switch to the console. Refresh this page. Go to editor, edit settings, go to manage, refresh. I forgot to change the location. Change it to Mumbai. Refresh. And then I go to settings, manage, For some reason, I'm unable to view the query result location, which should be our Athena bucket. If we switch to default work group, there you can see that these are the default work group default settings. It says that the query result location is this. When I click acknowledge and go to settings, now our group is default, but still I'm unable to view. I'm not sure why. So from our Terraform code, the query result location for the primary work group should have been updated as Athena bucket. So let's continue. We should create the database tables in Athena to query the ALB access logs. Let's do that. Before that, if you want to see the outputs of our Terraform apply, we have to add the output variables to our main.tf file. Let's do that before executing the query. This is the code. Paste and save the file. Run apply. So that gave us four outputs: the DNS name of ALB, the ALB logs bucket name, ID of subnet 1 and subnet 2. So this is how you can print the outputs from resource creation. Let's go to Athena and create a new database called ALB underscore DB. Run this. This has created a new database called ALB underscore DB. Let's create a new table called ALB logs partitioned. I've added this query in queries.txt file in my repository. Run this. So that has created a new table called ALB logs partitioned. Select from the table. Nothing is returned. Let's alter the table to add a partition. So this is going to return you all the logs for today's date, that is 23rd January 2024. Run this command. So this is the partition. Now select from the table. So that is going to give you all the access logs from application load balancer. So this is how you query the ALB logs. So that's it for today. Thank you so much. I forgot to show you the IAPO test bucket Athena. So if you refresh, you can see multiple files have been added to this bucket. So that shows we have correctly configured this bucket as the output query location for Athena. Let's see if you're able to see that. I'm not sure, but definitely we have configured this bucket as the output query location for Athena. That's it. Thank you. Bye.